In our second example of the maximization of revenue, we have a farmer's dilemma. This cherry farmer must decide when to harvest the crops. Here's the options. If he or she harvests now, the yield will be 20 pounds of cherries per tree. Right now, the market price is $5 a pound. Cherries are in demand. But now, as we get more and more into the season, the yield is going to go up. So for each week that he or she waits, the yield will increase by 2 pounds per tree. However, when everybody has all those more cherries going into the market, it makes sense that the market price is going to decrease. So at the same time, for each week that's waited, the market price is going to decrease by 25 cents a pound. So you're going to get more, but you're going to be able to sell it for less. What am I to do as the farmer? When is the optimal time to harvest this crop? All right, another optimization problem. What's the optimal time? What does optimal mean? Optimal, of course, means maximum revenue because right here it doesn't talk about the costs at all. So all we have to work with is how much money are we going to make? What's our total revenue? So that's what we want to maximize. Okay, so first let's try to make sense of a function that we can maximize, which is going to be revenue. And because it doesn't say how many trees are on the farm, we just have to give the revenue in the units of dollars per tree. Okay, I like to write the units down because when I try to form my functions, the units for each piece should cancel or add or whatever appropriately and get me the units that I'm interested in. So my revenue I'm interested in is going to be in dollars per tree. And that's going to be equal to the price in dollars per pound multiplied by the yield, which is going to be in pounds per tree. You see, now that I've written down this product here, when I look at the units, the pounds on the bottom here is going to cancel with the pounds on the top, so I'll be left with dollars per tree, and that's what I thought my total revenue should be in. I don't know how many trees are on this farm, so I have to consider what's my revenue in dollars per tree. Okay, cool. So my overall goal here is going to be find the absolute maximum of that function. But what really is it a function of? Usually we have our total revenue as a function of the number of items or something like that. But here you can see the question is a question of time. When? When is the optimal time? So I must pose this as my revenue being a function of time. It depends on when I pick it to tell me how much money I'm going to get off each tree. Okay, the price depends on time, and it does so in a linear fashion, and that can be seen by the statement that it's going to increase by a fixed amount for a fixed amount of time. Likewise, the yield depends on time, and that also occurs in a linear fashion. And so if I let my variable t be equal to the number of weeks from now, then my total revenue is going to depend on the number of weeks from now that I decide to harvest, and that will be the price at that time times the yield per tree at that time. And so my goal is going to be to find the absolute max of R of t as a function of t. If the answer is to harvest now, then I should get t equals 0 as the answer. Hopefully the answer isn't to have harvested earlier because it's too late for that, right? So I'm expecting t to be as an answer greater or equal to 0. Okay, so let's get started with the formation of R of t. So you can see that I'm going to have to form my price function and I'm going to have to form my yield function. And those are both linear functions. And if you saw the previous video on the maximizing revenue number 1, I showed you how to reminded you how to form a linear price function. Okay, so the first step here is going to be to look for P of t is something t plus something, where this is going to be the x, and that's the m, that's the b. And then x of t is going to be another block where we're going to put the slope plus another block where we're going to put the b. Oh man, so does that mean we have to go find a pair of points for each one of these unknown lines and then find the slope and find the b and do all that stuff you saw in the previous video? It could if you want to do it that way, but sometimes there's a shortcut. And I really like it when there's a shortcut because, of course, the best mathematician is a lazy one. Okay, so can we possibly find any shortcuts? One shortcut I could think of is that we actually have information about right now. And right now, when t is equal to the number of weeks from now means t equals 0. Okay? T equals 0 is synonymous with the y-intercept, right? Because that's the place where x equals 0. So actually I've already been given the b because I've been given the values of both of these functions when the x-type variable, in this case t, is equal to 0. Okay, so that means if I plug in t equals 0, you can see if I plug in t equals 0 on either of these, this whole thing disappears. And I'm just left with this box, and so lucky me, that's the information they've given me in these numbers right here. Okay, when t equals 0, the yield is $20 per pound. So if x represents the yield here, then when this is 0, this is 20 pounds per tree. So that's 20 pounds per tree when time is right now. Okay, you see how I did that? I already filled in one box in a shortcut way. The price, what's the price right now? 5, okay, so if I plugged in t equals 0 to here, this part would go away and there would be a 5 there. Nice. So actually I'm kind of doing it backwards. Usually I have to find the m first, but in this case, lucky me, they just gave me the b inside the words. But did they also give me the m right inside the word that I can use as a hint? Do you think I could be that lucky today? It says yield increases by 2 pounds per tree for each week that he waits. Okay, and remember t is the number of weeks from now. So like if I waited 1 week, then it would go up by 2. If I waited 2 weeks, it would go up by 4. So if that's the yield, what's the slope? What are they trying to say there? The slope is 2, exactly, because it's 2 pounds of increase per week that I wait. And it makes sense here because right now when t is 0, I get 20 pounds per tree. In 1 week, I would have 22. In 2 weeks, I would have 24, etc. Shortcut way. All right. Can you do it again for the market price? So what do you think is the slope on this function right here? This is the price function. What am I going to put inside the m box using that information? What did you put? 0.25? Close. Negative 0.25? Exactly. Because it's going down. It's going down by 25 cents per pound for every week that I wait, and that's because there's more cherries in the market, so I have to put that negative sign in there. Okay, cool. So we filled in both of these boxes, and remember that our total function, total revenue, is going to be p times x, and so that's going to be negative 0.25t plus 5 multiplied by 2t plus 20. And so what we're really after is what is the absolute maximum of this function. Would you like to see that function in another way? Maybe, because the next thing I'm going to do is say take the derivative, set the derivative equal to 0, classify with the first derivative test. All that stuff has to be done. And I don't really like how it's written right now as a product because it would force me to have to use the product rule. Okay, so you could. That's totally fine. If you want to use the product rule to take the derivative in this form, go for it. But another thing you could do is actually FOIL it out. Remember foiling? So we just have the two factors right here, and so the t squared factor is going to be negative 0.5 t squared. And then the linear factor is going to be comboing negative 0.25 times 20 with 5 times 2. So that's 10 minus 5. So that's plus 5t right there. And then the last factor is going to be the two constants, 5 times 20. So that's plus 100. And so this is my r of t. All right, keep in mind, I didn't take the derivative yet. I'm just trying to set it up so the derivative is as easy as possible for me to take. And you can see that this way, I'll be easier to take the derivative than to use the product rule of those products. Okay, you want to just go and do the rest of the problem? Yeah, because it's up to you to learn this stuff, right? So that's the goal. Find the absolute max of that function using calculus. There's actually another way. If you took Math 147, you can recognize this as a quadratic form, another down-facing parabola, and so its absolute max is again going to be located at the vertex. But we can also prove that using calculus by taking the derivative. That's going to be equal to negative t plus 5. Set that equal to 0. See, calculus isn't so bad sometimes. This solves out pretty easily. T is equal to 5. And is that the answer? Well, don't be too hasty. Make sure that if you're going this route using calculus, you confirm that you have what you want, which is a relative max in this case, as opposed to a min or an HPI. You can do that either by performing the first derivative sine number line like this, or what you can do is you can take a graph of the revenue function like this and see that t equals 5 locates the max. Not only is it a relative max, but it sure enough is an absolute max because we have that down-facing parabola. Okay, so the answer is going to be 5 weeks from now. Did we answer the question? When is the optimal time to harvest? Answer, 5 weeks from now. If the question was, what is the maximum possible revenue, would you know how to answer that question? Oh, I think I even answered that question. Okay, so the first question is, when is the optimal time to harvest? But let's throw another question in there. See if you can answer this one too. What is the maximum possible revenue? What's that going to be? It happens 5 weeks from now, and it turns out to be whatever comes out of this function right here when I plug in t equals 5. Okay, so I put t equals 5 right there, and I get that r of 5 is equal to 112.5. Hopefully you got that. And what's the units on that? Do you guys remember what the units were? I had it on earlier, but it's always good to try to keep it in mind. 112.5 what? Dollars per tree. Right, so hopefully I've got lots of trees on that farm because I'm going to get over $100 per tree. And keep in mind, if I had harvested right now, how much would I make off each tree if I get 20 pounds at $5 a pound off each tree right now? 5 times 20, that's 100, right? So if I did it right now, I'd only get $100. If I did it next week, I'd get a little more. The week after that, a little more. But when is the best time for me to do it? It's going to be 5 weeks from now, and I'll end up getting $112.50 per tree.